So what I'm going to do here is to simply walk through as a review and hope that it helps you to pass the exam. So we talked about the exam as having three parts: part 1, part 2, and part 3. Part 1 is the definitions, and we talked about these things. These are 50 multiple choice questions. It really goes through the CPM, the Counting Practices Manual, part 1. We go through and we talk about part 2, 3, and 5, which are the appendices and the glossary. You will have an online version, PDF version of the Counting Practices Manual 4.3.1. The important parts for you to look at for part 1 and part 2 for the definitions, and part 2 the application questions for the exam, are going to be to take a look at the first part, which are the rules, and the last part, which is the appendices, which are my calculations and your calculations, and the glossary. So part 1 is purely definitions. Part 2 is 50 multiple choice questions about equations, about actually applying the rules and the definitions to some samples that we did in class. And then part 3 is 2 to 3 case studies with about 50 to 55 little items that you'll have. Remember, we talked about they will give you blank lines to enter the information. You need to get a 90% average across all 3 parts, with no part less than 80% to get a CFPS, a Certified Function Point Specialist. If you get 80% average across, with no part less than 70%, you will be granted what is called a Certified Function Point Practitioner, or CFPP. I want you to get the CFPS, and I really hope that you will be able to do this. So let's go through a review, if that's okay with you. So first thing, we want you to remain calm and pace yourself. That means trying to remain calm. Read through the questions. We have the Counting Practices Manual, that's what CPM is, as an online reference, but you want to only look at that if you absolutely need to. Double check your mathematics. Double check that you've got the equations correct, and there will be an online calculator on the monitor or the laptop that you'll be using. Do not attempt to look up every single answer, and don't leave any of the questions blank. If you have to guess, if you run out of time, just make sure that you have an answer that you think is the best. If you completely run out of time, then just guess. Don't leave any questions unanswered, because if you leave a question unanswered with no answer at all, it will be marked incorrect. And this is mostly for my North American people, don't worry if you end up with C, 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 C as answers. That's okay. Select the most correct answer, and at least in the old version of the exam, you could not look at our quick reference card at the same time as you can open up the Counting Practices Manual. So it's important, if you've got paper or you've got blank paper in front of you, to write down the equations, and you can look those up really quickly. You could go to part 5 of the Counting Practices Manual, and you could write down the equations quickly. Watch for double negatives. These make us who are English speakers go crazy. So if it says all except, or which ones are false, or not including, or none of the above, make sure that you read that carefully. Watch out for questions that say onlys, things like all of the following, all of the above, or none of the above. Don't make assumptions, especially on case studies. Don't apply your analytical information. Just look purely at what the question says. And use the restroom or the bathroom or the washroom immediately before going to the exam. You don't want to have to use the toilet partway through the exam. It's just not good. So the Counting Practices Manual, as I mentioned to you, has 5 different parts. The calculations in the glossary are at the end. That's the last 70 pages. And that's where it says appendices and glossary. So what I would do when I go into the exam is I would immediately rush to and take a look at the calculations that are listed there. I would write them down. You want to write down how to count the development function point count. You want to write down how to do the enhancement project function point count. And you want to take a look at the application or base size. So my new development count is going to be a project count. And we'll talk about that in a minute. We've got an enhancement count, and that is kind of like doing a renovation project. When we have new functionality, we've changed some of the existing functionality, or we've removed some of the functionality that was there in a base application count. So the key things that you want to take a look at are the core definitions and rules, which are in part 1. And then you want to be able to quickly go and see the calculations in the glossary, which are going to help you very much answer the questions in part 1 of the exam, part 2 of the exam, and then on the case studies. So that's going to help you a lot. So as I mentioned, part 1 is the process, rules, and definitions. FSM means functional size measurement. Functional size, remember, is only taking a look at what the application will do. If I say, what does this software do? You can tell me it can add, it will change, it will revise, it will populate. Those types of things are really what we've talked about in the CRUD matrix: the change, the create, read, update, and delete. And my create is going to be an EI. My read is going to be an EQ. My U or update is going to be an EI. And the D in a CRUD matrix, CRUD, means delete, which would also be an EI. So we really want to take a look when you're looking online. If you can't remember a definition, and it really is going to take you a little bit of time to look it up, skip that question. Skip the question. You can bookmark it. You can go back to it at a later time when you've got a little bit more, less stress. If you've got your case studies done and you've got part 2 done, then you can go back and take a look at the definitions and do looking up the definitions so that you can pass the exam. This is just how to kind of relieve your stress, because I know it's a stressful thing to go into the exam. So let's take a look at definitions. Definitions are going to come in part 1 of the exam. So this is where you really need to know your glossary terms. And this is really kind of written, sometimes it's not easy to take a look at. But let's look at the definition of function point analysis. So if you see an exam question that says, function point analysis is defined as, or function point analysis is, then you know that's a definition. So function point analysis is a standard method for measuring software development and maintenance, and this is the keywords, from the user's point of view. Remember, the word user means any person, thing, other application, hardware, or software that exists around the sides of your software, and those are users. So when we talk about function point analysis, we're looking at a standard method for measuring the functionality, the software development and maintenance, from a user's point of view. So if something is not part of your software, it doesn't get counted. If it is manual, if it is done by hand, if somebody has to write something down or copy it separate from the software, then it's not going to be something we can count it. The word user view is a term that represents the formal description of the user's business needs in the user's language. Developers translate the user information into a business technology language. In other words, to provide a solution. So when we're talking about function points, we're talking about things from the user's point of view, or the user view. What are the objectives? Why do we do function point counting? And this is, if you see it says objectives, in the counting or in the on the exam, if it says what are the objectives of functional size measurement or function point counting, those are the same terms, the same words. Function point analysis measures software. That's the key thing. It measures software size by quantifying the functionality that the software provides to the user based primarily on logical design. So the objectives are to measure the functionality that the user requests and receives in the software, and it measures it, and this is absolutely critical, independently of the technology used for implementation. When we talk about implementation, we're talking about construction. We're talking about building. So when we measure software development and maintenance, we're measuring the functionality, not how we build, purely what the software does. The steps that are involved in function point counting. Now, I mentioned to you that there are functional size, there is non-functional, and then there is technical. Functional size, if you remember, is kind of like our floor plan for software. It describes all of the things that would answer, what does the software do? If I say to you how good or how good a quality or how portable or anything about the software in terms of non-functional, then that's going to be covered with the value adjustment factor. So here's the steps that we do if you're going to count a function point count. The first thing is we decide the type of function point count. Are we counting a project? In other words, the function points that we're developing or renovating. And remember, we talked about kind of like a house, the brand new areas. Any enhanced areas would be an enhancement project, and we can have conversion functionality. That's when we have migration, or we're converting to databases, or we have a user that requires specific reports that have to be run for an old system and a new system. So if we migrate data, if we convert data or something like that, that would be counted as conversion functionality, and we get function points for that. You could have an external input, you could have an external output, you could have an external query, you can have ILFs and EIFs that can be conversion functionality. Those become part of the project only. They do not go into the application. So I could have a project that has 100 function points of conversion functionality, and it would be 0 application function points that would be added to my application. So conversion functionality, don't forget, that's only for new development or enhancement projects. The application is how big is this software at rest? How big is it at a point in time? How many function points are sitting there today? So that's the first thing. We decide if we're going to be counting a project or if we're counting something that's already in place, an application. Second thing we do is we identify the counting scope and the application boundary. Now remember, the application boundary is a conceptual interface. It's not determined by the hardware, it's not determined by physical, it's determined on functionality. Users or actors in object-oriented, users are outside my application boundary. So what we have inside is my internal logical files, and we have external inputs crossing the boundary inside. We have external outputs and queries crossing the boundary to the outside. So we want to determine the unadjusted function point count. And to do this, we count our data functions. So when you see the words on the exam, data functions, that means ILF or EIF. We count those up to determine the contribution to the unadjusted function point count. Once we've done that, we've counted all of our data, all of our internal data that we maintain, and all of the external data that we reference. We then take a look at the manipulation of that data. We take a look at EIs, which come across our boundary and are either going to update an ILF or control the behavior of the system, trigger something to happen. We've also counted things that are going to be leaving our system, outputs and queries. And these are all what we call elementary processes. So when you see the words data functions, you should immediately think of ILF or EIF. When you hear the words or see the words on the exam, transactional functions, that means EI or EO or EQ. So we count these things all up and we determine the functional size. The functional size is my unadjusted function points. Now on the exam, they're going to have you calculate the value adjustment factor. That's our non-functional requirements. So those are things like my LDs, my data communication, those types of things. And my value adjustment factor gets multiplied by my unadjusted count to get my adjusted function point count. My adjusted function point count is my functional size multiplied by the effects or the impact of my non-functional requirements. Key definitions. Now definitions, remember this is going to apply to part 1 of the exam. So the word control information. Control information is data that influences an elementary process of the application that we're counting. So control data says what, when, or how we're going to process data. Those are things like show me, present to me, greater than, less than. So if I have a requirement that says I need to see all employees earning greater than 1,000 ringgits, then control information says all employees greater than 1,000 ringgits. And that's what we would take a look at. Control information is part of external inputs, and it can be part of external outputs or queries as well. So control information is data that influences an elementary process. And remember, our elementary processes are 5 types. We've got 2 types of data and 3 types of transactional. And those are the different types of functions we count. User identifiable. When we're talking about ILFs and EIFs, and we talk about user identifiable data, that's the data that refers to defined requirements for processes, so EIs, EOs, EQs, and or groups of data that are agreed upon and understood by both the users and software developers. That's kind of clumsy, isn't it? That's kind of confusing. What this means is user identifiable. This is the data that a user would specify. So when I was talking about indexes, or things that a user wouldn't know about, things that are there because of physical implementation, those would not be user identifiable. So we're talking about things that the users and the business requires. So my master data, those types of things. The word user, again, is a person that specifies my functional user requirements, or any person or thing that communicates or interacts with the software at any time. So that means users send data into the boundary to ask for an output or a query. It would be things like show me, present to me, give me, and then gets the data in return. Or it sends data across that causes one or more of my internal logical files to be updated. So that's a user, any person or thing that either writes the requirements, or a user is somebody or another application or a piece of software or a group that sends or receives data into or out of my application, out of my software. Maintain, that word maintained means the ability to modify data, to update data. So when we talk about an ILF must be maintained, we mean that the ILF, the data in the ILF, so my customer name, address, things like that, that we must be able to change it. So if you have an ILF that has no maintenance, then it is an EIF. That means it is reference only. An ILF must be maintained. In other words, we need to have an add, a change, a delete, these types of words, create, update, assign. Those are all ways of maintaining the data in an internal logical file. We've got the word elementary process. Elementary process means the smallest unit of activity that is meaningful to the user. It's kind of like a unit of work. An elementary process must be self-contained and leave the business of the application being counted in a consistent state. Typically, this question is on the exam. What is an elementary process? And it will give you a choice of A, B, C, and then probably all of the above. Processing logic. Processing logic is defined as requirements specifically requested by the user. Again, this is user-focused to complete an elementary process. So look at that quick reference card that I handed out in class. And on the front, all of those things are forms of processing logic. So things like edits or calculations or things like that. So EOs and EQs, if you remember, they must present data to an outside user. So data must cross the boundary out, and that's the primary intent for an EO or an EQ. Remember, EQs cannot, here's the 4 things that they cannot do. They cannot do calculations, they cannot update an ILF, they cannot derive data, create new data, they cannot change the behavior. We must have at least one ILF or EIF referenced. In other words, we must have one FTR or file type referenced for something to be counted as an EQ. Now, an EO, external output, must have either one calculation and or update an ILF or derive data or change the behavior of the system. An EO sends data outside the boundary, but it must do one of these things. So if you're presented with a report and there's a calculation on the report, you know it must be an EO. If you have a report and in your case study it says this report comes out and we update the employee file to show that a check was produced, then we know it must be that process of updating the ILF and preparing the report would be an EO. An EI, remember, an external input, must take data into the software across a boundary to update an ILF. It can also change the behavior, so it can trigger something that could happen. So that's what an EI is. Let's take a look at the next one. So, 3 types of function point counts. We've got our development project and our enhancement project. So development project counts the functions provided to the users with the first installation of the software. We can have conversion functionality that happens as part of a development project. When we complete a development project and it's in place, we then have an application count. So whatever we've developed, not including the conversion, will be put into the application count. Then we go and we do an enhancement project. An enhancement project, remember, is kind of like putting a piece of tracing paper, a paper you can see through, on top of my application. And we go in and we change things. So it's kind of like renovating a house. We might add new area, add new functional area. We might create new reports that we didn't have before. We might have new data entry processes. We might change some existing user functions. So we might renovate. We might have had a report that we've added fields to, or we have a report that we changed the calculations, or a report that we've changed the processing logic. If any of those things change, we count that area as it looks after the project as part of that enhancement project. We might also remove some user functionality. We might no longer need some data entry. We might remove some EI processes. That gets counted as part of my enhancement project. At the end of the enhancement project, we again have to update how big is the software that's in place. So the application is function points that are at rest. How big is this software today? So after doing an enhancement project, we have to take the old application size, add in anything new, add in anything that's changed, but subtract out that changed area as it was before, and then subtract off anything that we've deleted. And that ends up being our function point count of our application at the second point in time. Once again, enhancement projects can have conversion functionality. Conversion functionality are only part of a project. They are never installed in the application. Well, not never, but 99% of the time. They're not put into the application. So they're never part of the application baseline. If you see the word baseline, baseline equals application. Identifying the purpose of a function point count. That determines if we want to find out how much will it cost to deliver phase 1 of a project. What would that tell you? Well, the purpose of the count would be to figure out how big is phase 1. So that would be a project count. That would be a development project. It influences the positioning of the boundary between our software under review. Now, what software under review really means is that's the software we're counting. So when you see the word software under review, that means it's something that's included in what we're counting. And the surrounding software, in other words, it influences where we draw the boundary between what we're counting and other pieces of software, in other words, other users. We then identify the counting scope. And again, this is a definitional thing. A definition of counting scope defines a set or subset of functionality of the software being sized. It's determined by the purpose for doing the count, identifies which functions will be included, so to provide answers that are relevant to the purpose. So if I want to count phase 1, I'm only going to count those functions in phase 1. And the counting scope, as we mentioned in class, might include more than one boundary. So we might have multiple application boundaries within a scope, and then we would have to do multiple function point counts. Identifying the application boundary, we take a look at what is external to my application. Remember, the word application and software are used interchangeably. It's a conceptual interface between the internal software or the internal application and what sits outside my external user world. It acts as a membrane. In other words, it's kind of a border. If you think of it kind of like a piece of plastic, data flows into the application and data flows out of the application. So in order to be an EI, we must have data crossing into the application. In order for something to be an EO or an EQ, we must have data leaving our application. And our boundary tells us what's in our ILFs and what are the things that are external in our EIFs. Following rules apply for boundaries based on the user's point of view. The focus is on what the user can understand and describe. When we're looking at the application boundary between two pieces of software, so related applications, two pieces of software, it's based on separate functional areas, not on technical, not on my physical considerations, but based on functionality splits. Initial boundary already established for the application. In other words, my initial boundary doesn't change. I don't change my boundary of what's in a piece of software based on what's phase 1 or phase 2 or things like that. So my boundary does not change. And we might have more than one application, and then we would have more than one function point count and more than one application boundary. Functional components. When we're talking about components or data functions, we're talking about ILFs or EIFs. When we're talking about function types, we've got two types of function types. We've got data function types and we've got transactional function types. So the minute you hear data function, think of ILF or EIF. The minute that you read transactional functions or elementary processes, think EIs, EOs, EQs. Data functions represent the functionality provided to meet internal and external data requirements. So again, there's that word data. We count up the data function types, our ILFs and our EIFs, to figure out our unadjusted function point count. Internal logical files are user identifiable, and again, you've just got to memorize this definition. User identifiable group of logically related data or control information. The keyword is maintained within the boundary of the application. The primary intent of an ILF, the core reason, primary intent is why do we have an ILF? It's to hold the data that we're going to be maintaining using our EIs. So it holds the data maintained by an EI. It could also hold the data that we're maintaining as part of an EO process. So my primary intent of an ILF is that we're maintaining data for my software. So my master files. An ILF exists when the group of data or control information is logical and user identifiable, and we have at least one external input or EO that is maintaining the data on my internal logical file. Remember that the word FILE, ILF, in other words, file, means entity, means group of data. It's not a table, it means a group of data or an entity when you see ILF. So here's the example we had in class. The user requires that an employee must be, when you see the word must be equals mandatory. So an employee must be either salaried or hourly. That means it has to be one or the other. That tells me I have two record element types. I have two subgroupings of data. It must be one or the other. Either type may have dependent information. That means I have an optional subgroup, an optional RET. And remember, record element types or RETs can be mandatory or optional. The user requires all information before an employee record is considered complete. This means that a dependent is only identified in the context of one and only one employee. If I delete the employee in this business model, the dependent disappears. It also is deleted. That means this one ILF consists of an employee, salaried or hourly, that's two RETs, and a dependent, which is optional. So we've got three record element types, one ILF. Example, a flat file, so a flat assemblage of data, master file. When we look at it from a logical point of view, it contains these groups. It contains employee demographic. Demographic means name, address, phone number. The word demographic means characteristics about an employee. In other words, a description. If I say, what is your demographic? Or you ask me what my demographic is, I would say I am Carol Dekkers. I live in Florida. Here is my address. Here's when I was born. That would be my demographic. That word demographic means a description. So we've got employee information. We've also got customer information in a separate group of data on that same physical file. And then we've got expense report information. And then I've also got these two tables of code value information. So what can I count? Well, the user maintains all of those, so it might seem like I've got 5 groups of data, but remember, and this is really important, code tables don't count. So I would count one ILF for the employee information, one ILF for the customer information, one ILF for the expense report information. These are maintained. That's important. But the code tables, there's 0 function points, so those do not count. So these 3 different groups of data, each would have one RET. If you don't know how many RETs, it defaults to 1. We always have one RET. So 3 ILFs, one RET on each one. Every record is the same. The code tables do not count. EIFs, remember, an EIF is all the data that is maintained somewhere else. So data that we reference only. The primary intent of an EIF is to hold data referenced. So in other words, we need to reference the data from another system or another piece of software in order to put descriptions or to validate or add things to a report. An EIF is an ILF somewhere else. An EIF is a group of data or control information that is logical. It can't be code tables. Code tables can't be ILFs. They can't be EIFs. They can't be EIs, EOs, EQs. Code data doesn't count for anything. So an EIF exists when all of these things, the data or control information is logical and user identifiable. It's referenced by, and it sits somewhere else than our software that we're counting. The group of data is not maintained by our application, and the group of data is somewhere else as an ILF. EIFs can be shared between applications. It's information that we just reference. So it's not a file of transactions, even though it might sound like an interface file. If it contains transactions that we use to update, then remember that's an EI. So it's data that we only look at to reference. So don't confuse files of transactions. Even though it sounds the same like an interface file, remember that EIFs are entities that sit somewhere else that we only look at. So if you're looking at data from another application, including, say, names of employees that we read somewhere else and we include on our reports, that would be an EIF. It's read-only use. Don't count anything that we update directly. If we update the data somewhere in our software, it becomes an ILF. So an example, we've got an employee master file from the HR system is referenced. And this is going to be on the exam. It'll say something like it's referenced or it's read to extract. So in other words, to take a look at the employee name and address to put on paychecks. We're not updating any files, any of our ILFs. We would count that file as an external interface file. So we're taking a look at it. We're only reading that. On the other hand, and this is completely opposite, a payroll time file contains transactions that we use to update our system. We would count those transactions as one or more external inputs. So if my paymaster file comes in and it contains new employees, updated employees, and deleted employees, then we would have a create, an update, and a delete external input. So even though the paymaster file comes in one physical assembly, it really contains three separate EIs. We've got new, we've got updated, and we've got delete. Three separate processes. Think about it. If it were an online system, we would have an add, a change, and a delete process. So that would be three EIs. We've got this idea of unadjusted function points. We've got functional user requirements. That's what we count in function points. We've got quality requirements or non-functional requirements. Those are the things that we count with our value adjustment factor. And then we've got technical requirements. Those are things like Oracle or Sybase. Those are how we build. Those are not counted at all. Functional user requirements are all the functions we count. Quality requirements are all of the things that we count using the value adjustment factor. And technical requirements, those don't count at all. Functional user requirements, this will be on the exam probably in part 1. It's a subset of our user requirements. It's the user practices and procedures that the software must do. Does not include quality requirements, does not include technical requirements. It's what the software does. That's what we count in function points. Quality requirements, those are our value adjustment factor. That's how good does it have to be? How fast? How good? How much communication? all of those types of things that are in our value adjustment factor. Our quality. Technical requirements, those are things that have to do with my architecture. That's how my software will be built. And examples are my programming language, what are my tools, those types of things. We don't count those in function points at all. That's really kind of like having blueprints. And remember, we don't count that. We've got types of data entities that can be counted as ILFs or EIFs. We do count business data. We do count reference data. We do not count code data. Business data, function points are yes. Core user data or business objects. It reflects the information needed to be stored and retrieved. It's usually a significant portion. These are mandatory. They're user identifiable. They're user maintainable. And it's our master data. It's our master file. So business data, function points are yes. Reference data, that's stored to support the business rules. They're mandatory. They're not substitutable. It stores the data to support core user activities. It's kind of like business rules. Function points, yes, we do count that. Code data, function points are no. These are translation. These are only substitutable. So it's things like my name is Carol. So I might just store that as C. But every time you see the word C, you substitute it for Carol. Now, if we had Carol and my height, that's not substitutable. It's only when it's substitutable data. So it's like an abbreviation or a shortcut. So instead of Kuala Lumpur, we have KL. Instead of Malacca, we have ML. Those are substitutable. And the only reason we have those is because they don't take up as much space. Provides a list of valid values. So if we've got a code description, it doesn't count as an ILF, it does not count as an EIF, it does not count in EIs, EOs, EQs, it does not count as FTRs. Code data doesn't count. If I have a drop-down list of hard-coded data, for example, yes, no, or a Y or an N, or KL for Kuala Lumpur, if those are in drop-down boxes, that can't count as EQs ever. So code data does not count. Now, when you're going through, if you want to re-listen to this webinar, there's some examples here of what are reference versus code. So reference data are things like financial amounts, exchange rates, tax rates, any of those types of things. If it's not substitutable, control data is user-maintained data that contains business rules, calculations, or things like that. Currency exchange rate, the US dollar to ringgit exchange rate. That information would be counted as business data, so yes, we would get function point counts. Tax rate ranges, upper and lower limits, those types of things. We can't substitute those. So in other words, those aren't just shortcuts. That would count. Reference data, yes, does get function points. Code data does not. So when we take a look at three types of transactional functions, EIs, external inputs, EOs, external outputs, and EQs, external queries. So we count these up. An external input has data or control information that comes from outside the application boundary. The primary intent of an EI is to maintain one or more internal logical files, so the data that we're maintaining are master files, or alter the behavior of the system. In other words, trigger something to happen that wouldn't have happened. Rules to identify EIs. You need to know these absolutely positively. If we've got two different EIs or two different processes coming in and we want to know, is it exactly the same or is it different? For the identified process, one of the following three must apply. So I'm comparing one to the other. So if they have identical processing logic and identical DETs and identical ILFs or EIFs, then I know it's an identical function. It would be counted once. If any of those three are different, Then for the identified process, one of the following must apply. So if my processing logic is different, or I've got different data elements, or my ILFs or EIFs are different between process 1 and process 2, then we would count both processes as being unique elementary functions. External outputs is an elementary process that generates data or control information sent outside the application boundary. The primary intent of an external output is to present information to a user that includes retrieval of data, typically, and it must contain a formula or calculation or create derived data. It can maintain an ILF, and it might alter the behavior. So those are those 4 things that we were talking about. Remember, calculations, derived data, updating an ILF, and altering the behavior. One of those things has to happen in order for something to be counted as an external output. Hints to count external outputs. I'm going to go very quickly through this. We want to take a look at anything that's derived, anything that's batch or online that has calculations. It has to be user requested. We take a look at anything with detail and summary. If it's got a summary, then you know there's an external output. External queries are exactly the same primary intent as an EO. Is to send data outside the boundaries, so across the application boundary outside, and it contains no math, no calculations, no derived data. Excuse me, I'm just going to turn that off. That gives you a little bit of a break. So the processing logic is unique. If I'm comparing 2 EOs or 2 EQs, if they're exactly the same, in other words, the same ILFs, the same data elements, and the same processing logic, you count it once. That's what we mean by this. Hints for counting EOs and EQs, you can take a look at this. It has to be self-contained. So if I've got a query where I've got an input side that says show me, present to me, give to me, I've got an output side that is produced for me, we need to count both of those together. My question and my answer together is my elementary process. Here's my functional complexity. So if you're looking on the exam and it says, what is the functional complexity? That means, is it low, average, or high? So if it says, what is the functional complexity, and you say it's 7 function points, that's incorrect. The functional complexity means, is it low, average, or high? So for our logical files, our ILFs or our EIFs, our data functions, we have one matrix that's shared, and it has RETs or record element types across the row headings, and it has DETs, our data element types, across the column headings. Remember, it follows the diagonal is average, the low is in the upper left, and the high is along the bottom right. ILFs and EIFs have different function points, but they use the same matrix. External inputs have their own matrix, and it's dependent on FTRs. FTR, again, is file type reference. That's how many ILFs or EIFs do I need to complete the process. And DETs, the number of data element types, number of data fields, non-repeated. Then we've got our external outputs and our external query complexity, and they share a matrix. Now remember, an external query must have one FTR. Must have one FTR. If an external query does not have one FTR, does not reference an ILF or an EIF, it cannot be an external query. External outputs could have 0 FTRs. I'll say that again. An external output can have 0 FTRs. Now you'll notice external inputs could have 0 FTRs. How is that? Well, if it doesn't update an ILF and it's just modifying my behavior, it's control information that says close a valve, the pressure is too low, or do this, or do that, and it doesn't, and the primary intent is to send data into my application, it may not update an ILF. So that's why we have a 0 FTR for external inputs, and that's why we can have 0 FTR for an external output. But an external query must have at least one ILF or EIF that it is referencing and taking data from. General system characteristics. So far, we've counted the unadjusted function point size. When we're talking about functional size means unadjusted function points. My unadjusted function point size, we then adjusted based on non-functional, which are considered user and business constraints. So if you see the word constraints or non-functional, those are the same thing. So my value adjustment factor, my VAF, is based on assessment. In other words, evaluating or scoring or taking a look at the 14 general system characteristics and determining what is called the degree of influence. The degree of influence means, do I have a number between 0 and 5? Remember, degree of influence is that score 0 through 5 on each of these general system characteristics. And my GSCs, or my general system characteristics, are all of those factors, all of those characteristics, like data communications. And I know these words are tough, and it really takes memorizing. So if I said, what's the degree of influence? You'd need to know that that is a number between 0 and 5 that I evaluated general system characteristic. So we add up, we total the degrees of influence. We add up all of the 14 characteristics to get what's called the TDI, or total degree of influence. That's just the sum of all of those 14 characteristics. So the minimum of 0, the maximum would be 70. If I had 5s on every one of those 14 characteristics, and I added up all of those 5s, it would add up to 70. So my value adjustment factor can range between 0.65, that's if every degree of influence, every answer to my general system characteristics is 0. Then I would get a 0 in the first part, add it to 0.65. That means my value adjustment factor for very, very simple systems would be 0.65. The maximum for a value adjustment factor is if every single one of those general system characteristics ended up being a 5. So that would give me 70 times 0.01, which would give me a 0.7, plus 0.65. That would give me a 1.35 multiplier. So you need to know that the value adjustment factor can vary between a low of 0.65 up to a maximum of 1.35. Now the exam might try and trick you, might try and confuse you by saying something like the TDI ranges from 0.65 to 1.35. No, the TDI, the total number, the total summation, can range between 0 and 70. The value adjustment factor ranges between 0.65 and 1.35. I'll say that again. The value adjustment factor, or VAF, ranges from 0.65 to 1.35. The TDI can be 0 up to a maximum of 70. Here's all of the general system characteristics, and I don't have time to go through them all, but you really need to read the definitions. And those are on the back side of the quick reference card that I gave you. So just make sure you know where things are. These are things that you may have to quickly look up at the end of the exam that you may want to skip over, but at least know what each of these things contains so that you can get it. The value adjustment factor, so 0.65 up to 1.35, here's the equation. And the adjusted function points is going to be my unadjusted multiplied by my value adjustment factor. Now you know that the equations are a little bit more difficult than this, and you need to write those down, or at least I do when I get into the exam. Things to remember. Count logical functionality, not physical. Count what the application does. So if I say to you, the application collects and stores. Collects and stores. The key word there is stores. That means we're going to maintain, we're going to keep consumer preference information. So that means I've got an ILF to store my consumer preference information. That's one entity, that would be an ILF. We collect it to store it. That means I've got an EI. Second idea might be that managers need the ability to add, change, and delete employee distribution groups. That means if I'm going to add, change, and delete, I've got 3 EIs and I've got an ILF. This is the type of thing that will be on the exam. It will say something like, we need the ability to add, change, and delete employee distribution. It may not say explicitly, we're going to store it. But if you add, change, and delete, you know that you will be storing it. So you would have an ILF. Here's another example. Users need to query and calculate the cost of a custom study. So we need to inquire. We need to create something that goes out. We need to calculate the cost of something. So that's going to be an EO. We're not storing anything. We're calculating a cost. That would be an EO. We have a requirement for monthly reports summarizing. The word you summarize, calculate, any of those things implies an EO. So if it says summarize, calculate, total, you know you've got an EO. Things that we don't count in the unadjusted function points. Menus and navigation. You need to know that is general system characteristic number 7, and user friendliness. Menus and navigation. PF keys, jumps, scroll bars, anything that makes it easier to do things. Templates, icons, drop-down boxes, all of those things are end user friendliness. That's general system characteristic number 7. Backups, recovery, archive files are not counted in unadjusted function points, but they would be counted in general system characteristic that covers data backup. And I think that is general system characteristic, I may be wrong, it's either 10 or 11. Backups, recovery, unless it's legally required. So if you have to keep tax file backups, and that's a regulation, it's a government requirement, then you would count it. But if it's normal backups, normal recovery, we have a general system characteristic that counts that. Performance or physical files, we can't count that at all. It's not a user requirement, that's how we built it. Distributed data processing or inter-platform, platform means how many pieces of hardware do we have. Distributed data processing is general system characteristic number 2. If I've reused code, I don't get function points for that. It would be general system characteristic number 10. Design or quality factors, if I've got complexity, I would look at general system characteristic number 9, which is complexity. Code tables don't get counted. Even if I need them, they're not countable. So in summary, we measure the size of software based on functional user requirements. Function points measure what the software must do. Function points are independent of the development methodology, independent of technology, implementation. It's independent of those. Because how we build does not affect my floor plan. So think about function points as answering the question, what will the software do? There's some example case studies we had. Here's the equations. Take a look at the equations in the section at the back in part 5 of the Counting Practices Manual and be aware of those. Take a look at that. And there's 2 equations you'd keep in mind for an enhancement case study, or for an enhancement function point count. We'd have our enhancement project count and we'd have our application at the end of it. Remember that conversion, that's that CFP. CFP or conversion function points get counted in the enhancement project or a new development project. It does not get counted as part of my application, or in other words, what's in place. So I could go through an example question, and I challenge you to go through. This is the type of question that will be on the exam, especially in part 2. Take a look at this, see what you come up with, and if you want to, you can send me an email to caroldekkers@gmail.com with your answer, and I'll take a look at it. So for further information, send me an email, caroldekkers@gmail.com or dekkers@qualityplustech.com. I really want you to pass this exam. Good luck on your exam. Be stress-free, peaceful, and you can always take the exam again. Thank you so much for taking this. Thank you so much for taking the exam, and good luck. I hope many of you pass. Have a great weekend ahead of you. Have a great week ahead of you. Study the glossary.